Today we are going to discuss about center of mass of an object. Consider a system. The system consists of n number of particles like this. It is having so many particles. M1 is the mass of the first one, M2, M3, M4 and Mn. The effective masses of all the particles in a system or in an object are supposed to be represented by a single point. That point is called center of mass. The effective masses of all particles in a system or in a body are represented by a single point. That imaginary point is called center of mass. For example, if you have two masses like this, M1 is the mass of the first one and M2 is the mass of the second one. Join a line by joining the centers of these two masses. Let M1 is the first mass and M2 is the second mass. So draw a line from the center of the first mass to the center of the second mass. Now you can imagine this as x-axis. Extend this, let it be x, and this as y-axis. Okay. Now you can calculate the center of mass of this two particle system. It may be, if M1 is equal to M2, the center of mass of this two particle system may lie exactly at the midpoint. If M1 is greater than M2, the center of mass shifts towards the bigger mass side, maybe here. If M2 is greater than M1, then the center of mass shifts towards the bigger mass M2, this side. Okay. So the position of the center of mass always depends upon the masses of the particles present in that system. It may be 2 particle system or 3 particle system or n number of particle system, whatever it is. The center of mass always represents the total mass of the system. That is called center of mass. How can we write the equation of center of mass for a 2 particle system? We have two masses, M1, M2. Now join a line, draw one line joining the centers of these two masses like this. Let it be x-axis, and draw another line perpendicular to these two masses. This can be taken as y-axis. Now M1 is mass of first object and M2 is mass of second object. Let the point C is the position of center of mass. Let x is the distance of center of mass from the origin. Let x1 is the distance of first mass from the center of M1 to the origin is x1, and from the center of M2 to the origin is x2. The distance from the center of the first mass to origin is x1. The distance between the center of the second mass and the origin is x2. Let x is the distance of center of mass from the origin. We don't know the value of x. We have to find out x value by knowing x1 and x2. What is the total mass of the system? M1 plus M2. This total mass is supposed to be represented by this imaginary point C. What is the distance of this point from origin? X. X into total mass of the system, M1 plus M2, must be equal to first mass times the distance of the mass from the origin plus second mass into its distance from the origin. From this you can write x equal to m1 x1 plus m2 x2 by m1 plus m2. This is the expression for center of mass for two particle system. For example, if you have n number of particles on x-axis, x1, x2, x3, x1, x2, x3, so on, xn are n number of particles situated on x-axis, x1, x2, x3, so on, xn are the distance of masses of m1, m2, m3, so on, mn situated on x-axis at distances x1, x2, x3, so on, xn. For example, we have so many m1, m2, m3, m4, m5, so on, mn. So many number of particles are presenting on x-axis. Each mass is at a distance x1, x2, x3, so on, xn from the origin. Now, how to write the expression for the center of mass of this n particle system? Xn is m1 x1 m2 x2 plus m3 x3 so on mn xn divided by total mass of the system m1 plus m2 plus m3 so on mn. So what is m1 plus m2 plus m3 so on mn? The total mass of the system. You can represent it by a capital M, or you can also write this as sigma I equal to 1 to n mi xi by capital M. This is the expression for center of mass. The value of I varies from 1 to n. So if it is 1 m1 x1, if it is 2 m2 x2 and so on. m1 plus m2 plus m3 so on mn. The total mass of this n particle system can be represented by capital M. So this is the expression for center of mass of n particles, and this is the expression for center of mass of two particle system. Now you can write the expressions for two particles lying in xy plane and also in space. Now let us see what is the expression for two particles that are lying in xy plane. Here we have two objects of masses x1 and x2 lying in xy plane like this. So if these two are lying in the same plane, how to represent this mass? x1, what is the position of this mass? x1, y1. What is the position of this mass? x2, y2. What is the mass of this first object? m1 is the mass of the first one and m2 is the mass of the second one. So if two masses are lying in xy plane, we need two coordinates to represent this mass. Now how to write the center of mass? May lie here or here or here, anywhere between the line joining m1 and m2. Okay. Now you can write xcm is m1 x1 plus m2 x2 by m1 plus m2. ycm is y coordinate of center of mass. xcm means x coordinate of center of mass. Center of mass C may be here or it may be here. Usually it may lie between the line joining these two masses. Let C is the center of mass. Now you are going to calculate the coordinates of center of mass. X coordinate is xcm, y coordinate of the center of mass is ycm. How can we write ycm? m1 y1 plus m2 y2 by m1 plus m2. You can extend this for n particle system. If it is n particle system, the expression for xcm is sigma, or first write the equation, after that we will take sigma. m1x1 plus m2x2 so on mn by m1 plus m2 so on mn. Similarly, ycm is m1y1 plus m2y2 so on mn by m1 plus m2 so on mn. So this can, in short, how to write this? Sigma I equal to 1 to n mi xi by capital M. What is capital M? Total mass of m1, m2 so on mn. Similarly, this can be written as sigma I equal to 1 to n mi yi. So you can represent like this also. For example, these three masses are lies in three-dimensional plane like this. One is in xy plane and the other two are in y and z planes. For example, one is like one mass is here, one mass is here, one mass is here. So to represent these particles we need three coordinates x, y and z. So in that case you can write z coordinate also. zcm is m1 z1 plus m2 z2 so on mn zn by cap m1 plus m2 so on mn. So zcm can also be written as sigma I equal to 1 to n mi zi. So if the object is lying on x-axis, we need only x coordinate to identify the center of mass. If the particle lies in xy plane, we need x and y coordinates to identify the center of mass. If the object lies in three-dimensional plane, we need x, y and z coordinates to identify the center of mass. Instead of x, y and z coordinates, you can take position vectors also. We know what is position vector. For example, if you take these masses are like this. Now R1 is the position vector of the first mass, R2 is the position vector of second mass and R3 is the position vector of third mass. Now you can take RCM, position vector of center of mass is m1 R1 plus m2 R2 so on mn Rn by m1 plus m2 plus so on mn. So this can be written as sigma I equal to 1 to n mi r. This is in terms of position vector. So to simplify the equation, we always take position vectors instead of x, y and z coordinates. Rather than taking xcm, ycm and zcm, you can take rcm. Then it is very easy to solve the equations. So that's why we always consider position vector for an object in three-dimensional plane.